Let's imagine designing materials at the incredible small scale, atom by atom. How can we modify their properties to make them more efficient? For example, in electronic or catalysis. One of the most promising tools is achieved is absorption of thiol onto tungsten disulfide nanocomposites. Through theoretical and computational research, we see how the simple molecular interaction can transform the electronic and structural properties for this material, opening the door to the new application in the future technology. My name is Gloria Maria Lopez Solano, a nanotechnology engineering student. I present to you electronic and structural effects on the thiol absorption on the WS2-BASED nanocomposites, a first principle investigation. Okay, before we begin, let's ask ourselves what thiol is. What is a thiol and what is a tungsten disulfide? What is a thiol? A thiol is an organic compound characterized by having a functional group, SH, called a thiol group, which is a sulfur compound of the hydroxyl group. What is a tungsten disulfide? Tungsten disulfide is the decalcogenator of transmission metal. These are 3D materials and physical properties that have application in electronic and optoelectronic. WS2 has a hexagonal crystal structure. In the figure 1, we can see the WS unit cell in plane X. This is sulfur and this is tungsten. To begin the research, we create a 4x4x1 supercell, as can you see here. They are characterized by having a sandwich type structure. Let's imagine that we have the sandwich. The two slices, the two red, will be the sulfur, and the interior will be the tungsten. We will perform the absorption of the thiol in the supercell. During the research is the L-cysteine and methanethiol. We observe the sulfur atom with the thiol with the sulfur of the supercell, hoping to significantly improve the semiconductor conduction. The question is, how do we do it? Using the first principle. In this case, we perform calculation implementing quantum espresso to model thiol interaction. As a first step, through the pseudo potential we will use choosing two families, BLIP and PPE. How to family? The resin using the journal pseudopotential with the be explained later. The next step was optimize WS2 with cutoff energy of the 100 array. The approximate step is create the 4x4x1 WS2 supercell with periodic layer. And the next step was the absorb the thiol sulfur at position of the WS2 to calculate the electronic properties finally. In the figure 7 and 8, we see the supercell observed with methanethiol and L-cysteine. For example, this is the supercell with the methanethiol, this is methanethiol, and supercell with cysteine, this is cysteine. Okay, here we show the band structure of the WS2 using to BLIP pseudopotential. Here Here we observe the indirect gap of the 1.89 electron volt, but this does not match as a direct gap is a step. This is reaction why we decide to use another pseudo potential, in this case PBE. But what about the behavior with the pseudo PBE? We can see this is a figure. Here we were able to apply into a direct gap of the 1.1618 electron volt at the cap point. This is gamma, M, and K point. Okay, through the research, we establishing a solid foundation for understanding the initial interaction between thiol and WS2 nanocomposites. As we have seen, our first principal methodology has allowed us to accurately model the structural effects of absorption, effectively energetically favorably the deviating size on the geometric configuration of the thiols on the surface. However, the work presents only the first part of the more complex site analysis. While we have clarified the style of the test configuration, the next crucial step is our research is a detailed evolution of their electrical properties. Calculating to the band structure of the test system is essential for understanding how thiol absorption modifies the energy gap and therefore their potential of the test material for application in optoelectronics. Thus, the result that we have presented today lay the run-up for promising the future research direction. We will continue this calculation to arrive the full effect of thiols, thereby obtain robust theoretical guidance for the design of materials with total electronic properties. Thank you and appreciate your attention.